All right, welcome back. It is COMP397 in the winter 2018 semester, and we are at Centennial College, week 5, part 1 of our broadcast. We're going to be talking about collisions today. But before we go there, for the people that are in this class, I made an announcement earlier in the first class that your first playable is due Monday now. I'm giving you an extension of a couple days for a couple of reasons. One, you don't have collisions, which I'm going to give you today. You don't have scoring, which I'm going to give you today. You don't have movement, which I'm going to give you today, like not mouse movement, like movement, right? And I wanted to give you all those things before Monday, so that way you have the code you need to build up your first playable a little better, right? So I give you a couple days. I didn't want to extend this thing until next week because that means you'd work all week, right? I don't want that to happen. Like throughout your break, you probably have other things you want to do. So that's why I'm making it due Monday. Okay, so for now, for the people who came in late, your first playable is due Monday. Excellent. I'm going to show, yes, the collision should work. I'm going to show you how everything works now. And what I want to try and do today, if I have time, is also show you how to put it up on GitHub pages. I kind of talked about it last week, but I want to show you how to do it this time. All right, so I've got my game from last week. If you remember that we were under Centennial College, we did Mail Pilot Demo B. Hey there. Daniel just announced that the first playable is due Monday. In a couple days. So I'm using Mail Pilot Demo B. Mail Pilot Demo B to start off today. And under my folders, I'm going to pull off. Here's Mail Pilot Demo B. I'm going to kind of start off my VS Code, drag and drop it. So this is where my start off point is going to be. And one of the biggest problems we have when we start off a game, we don't really have a game until we have collisions. So we're going to talk about that first, right? First, because we started this off for the first time, I'm going to press Command-Shift-B on a Mac or Control-Shift-B on a PC to start off my watch task so I can transpile automatically. And then I'm going to bring up my terminal window. And in my terminal window, I want to change my folder to the folder I'm working on right now, which is Mail Pilot, again, COMP397-2018. Mail Pilot Demo B, right? So I'm going to kind of go CD space and then just drag this in. Again, PC or Mac compatible, this thing, this command I just did. And when I'm in there, right, you can see that I have my files. That's fantastic. So what I want to do is see how this works. So I'm going to say light-server so I can see what the demo that I have going. Here's my Mail Pilot demo. This is how it works. So right now I have motion, right? I have my islands and my clouds moving, and I move with my mouse. Today, by the end of the day, I want to move with my keyboard, no more mouse, right? And I want to have collisions. I want to have a scoreboard that comes up here, and I want to put this up on the web if I can too. And I want to have sounds. Can I keep going what I want? All right, so all the stuff I want to put up, I already put up the first initial stuff up on GitHub. So we should have everything we need. All right, so how do I do all this stuff? Well, what's the first thing I got to do is think about some collisions. So think about collisions, right? I'm going to have my objects here, okay? So I have I put some stuff here already. I'm just going to pull this down for now because this is kind of my solution. Let's pull this down so I don't see it. But I want to think about this, right? I'm going to do some collisions, and there's different ways of doing my collisions. So before we start with the collision thing, I want to think about this, right? I can definitely calculate the distance between my objects, right? That's one way of doing it. And I can use a bounding box. But the problem with the bounding box, all right, and I'm just going to put this up into, I'll make a new scene. And I'm going to take some objects here. So I'm going to take these objects into my new scene, just from an explanation perspective. So there's the first type of collision is called aligned bounding box. First type of collision, or you also know it as AABB collision type. Okay. Axis aligned bounding box means I put a box around my objects, and then when they overlap, I'm just talking about concepts now, no code for it, right? When they overlap, I have a collision. So let's say for these two objects, let's zoom in, right? So I have these two objects, and let's see if they're colliding. So do I have a collision here? What do you think? Any collision? No. How about here? Is that a collision? Well, it's touching. Depends on how I do my, I'm not overlapping. It depends on how I do this. It may or may not be a collision. Okay, how about here? Do I have a collision here? Okay, how about here? How about here? How about here? So this is probably okay, but take a look at this. Even if I don't show, even if I don't have a visual collision, I have a logical collision. So what I might have is a problem like this, and I know some people have seen this already in my other demos, but you can see that here there's clearly no visual collision. It's close, but they're not visually colliding, right? But I have a logical collision, and that's a problem. In this case, it's not so small. I mean, it's not so big. But what about here? So I have a cloud, and I have my plane, right? I want to collide with my cloud. Do I have a collision here? What do you think? In the game? No, in the game. When I see the game, your player's playing. Should I be colliding there? But I shouldn't be colliding there. But guess what? Because axis aligned bounding boxes, I have two bounding boxes, and all I care about is overlap. This is a collision logically. My friends, this is no good. It'll look like weird, like it'll disappear. If your plane comes here and it goes crash, you're like, wait a minute, I got gypped. It shouldn't have happened, right? I got ripped off. I shouldn't be colliding here, right? So we need to find another way potentially of doing collisions. One way is to make these bounding boxes smaller. So I can take the bounding box and make it smaller, right? That's one thing I can do. But then you might have another situation. So if I take my bounding box, right, and I make it smaller than the actual object like this, right? Let's say slightly smaller. And let's just make it so that you can see it. And again, I'm just trying to demonstrate this so you guys can understand some of the issues around it, right? So here's my bounding box. And I only collide when I'm colliding with my bounding box. So I still have a bit of a problem here because, I mean, but I'm going to have definitely a problem here where I should be colliding and I'm not. So I have a visual collision and that's the other way around, but I don't have a logical collision. That's a problem too, right? So two problems. So axis aligned bounding box is great for simple collisions. When I have two objects that are square, they're exactly square. For example, a platform. If I have a square platform and I want to do axis aligned bounding box, if you're doing a platform game, that's great. Some kind of, like you guys here who are doing a platformer, axis aligned bounding box, you might want to look up the code for that. It's actually pretty good, right? Because you're just overlapping, right? But when it comes to the game we're making today, this may not work so good. The other type of collision is distance, which I kind of have here. And the reason why distance might work better for us is because of the following. So I have some kind of, right now I have in my objects half height. Here's half height and half width, right? And then I can figure out the Pythagorean distance between my object and the objects that I'm checking for, right? By the way, these collisions are occurring. The collision check is going to happen every frame. I got to check to see every frame that am I colliding? Am I colliding? Am I colliding? Right? And for these big objects, right, what I want to check is what I kind of had before when it's just kind of hidden down here, right? Which is, see if I can grab these things now. not distance, just this stuff. So I want to kind of do one of these. I want to kind of say, well, if my Pythagorean distance between the two centers is less than my player half height and my enemy half height, right? I have a collision. Would you agree that that's good? Y equals less than and not less than or equals. Because sometimes I don't want it just touching. I don't want just to touch the box. I want to pass through. It's only 1 pixel we're talking about, right? I'd rather have it so it's less than, which is for sure a collision, than equals, right? So this is the formula I recommend for today. A distance. But the problem that I'm having, I'm just going to tell you, this distance piece, Pythagorean distance, which means I need to use square root. Pythagorean distance means P2x minus P1x squared plus P2y minus P1y squared. Take the square root of that. And that's the distance between the 2 points. Distance between Pythagorean distance, right? If I do square root every frame, right? Square root calculations every frame are computationally expensive, right? So this is something that I got to figure out is maybe I don't want to do this, right? Because of computationally, how expensive computationally it can be. However, I could overcome this by doing squared distance. So instead of doing my distance formula is going to be square root, I won't do that. I say P2x minus P1x squared plus P2y minus P1y squared. If you take that, that's the squared distance and is less than player half height squared plus enemy half height squared. It's the same. It's relatively the same. I'm not doing square root. I'm just using squares, and it's okay. So I can avoid using square root. But we run into a bit of a performance problem, right? We've got to think about this. How about if my cloud is way out here? Want to grab that? So if my cloud is way up here, do I want to check? This is a trick question, right? Do I want to check collision with my plane if my cloud is up here? Is there a chance, any chance, that my plane can collide with my cloud up here? No. So should I start checking collisions up here, way up here with my cloud? Trick question. The answer is yes. So here's why it's yes. This is called narrow phase and broad phase collision. All right, so 2 phases. So imagine this is the broad phase. Again, theory, guys, right? So in my broad phase, this is a nice idea. Broad phase, right? And this is my narrow phase over here. Okay, so when I'm closer. So here's a problem, right? If I don't check collisions, if I don't reach this line, let's say, is the area that you want to start checking, right? Almost like my, I don't know what you want to call it, domain, my collision domain, right? And I'm moving my thing down here. So great performance up here, and I come down here, and all of a sudden I start doing narrow phase collisions, which means I'm going to go do this again, right? Over and over again. I'm going to keep checking with this. I do a square root, for the distance. I'm going to check the player height. I'm going to do this every frame, for every one of my objects. I'm going to keep doing this over and over again. I'm going to keep cycling, right? So what's going to happen is great performance, bad performance. Why? Because less checks, more checks. Okay. In a 2D game, we may not want this because our 2D game is running on a platform. It's the web. It's, you're not going to know if you're going to get 60 frames per second. You may not, depending on the browser, where they're playing it. There's too many variables, right? In a situation where narrow phase and broad phase is being run on a real CPU somewhere, right? And you're playing a game on for a PC, right? Or Mac or a console or something, you're probably not going to know this. And you might notice, and you might run narrow phase and broad phase checks somewhere else. Like, for example, maybe even on the GPU, right? So lots of performance, right? We have performance opportunities, right? When we have that kind of backing. But here on the web, you're going to have a performance slowdown. And even on your phone, if you try and run this thing, narrow phase and broad phase, you have a phone app, phone game, same. Because your phone has limited memory, limited performance for now, and you're going to have some kind of change in performance from broad phase to narrow phase, which means better to have a crappy game the whole time than to have a really good part and a really bad part, because then you have inconsistent performance. It's almost like it goes up and down, up and down, up and down. That's the trick question. So you might want to try and do it. You might think, hey, it's a great idea. Don't check, right? On the downside, if you have a game like ours, that's constantly moving, things are constantly moving, out and back, then you might want to think about always checking and not using broad phase, narrow phase. The more objects on the screen, the more performance is going to be dropped, right? Either way, you're going to feel it. That's what I'm saying, right? And if you do it this way, broad phase, narrow phase, you're going to feel it really a lot more, right? When they're closer to you. Once they're closer, ready to collide to you, then it's going to be like, oh my God, right? Lots of calculations are going on. I also have to mention, just for completeness, that there's another type of collision check we can do. And I made a really ugly drawing here, but it's called separated axis theorem. Separated axis theorem is, let's get rid of some of these lines for a second, right? Separated axis theorem, it looks at, the objects. What if, it poses this question, right? What if the objects aren't straight? What if the objects are moving or they're rotating or something else is happening, right? Like example, this object is falling and it's going to collide with this object here, right? I can't do AABB because it's the same problem I had before. AABB collision will fail, right? Because it's axis aligned bounding box. These boxes aren't aligned from an axis perspective. These are rotated, right? This is okay, and this is okay, but these two are not, right? So if I do some kind of an axis line bounding box works with the top left corner and the bottom left corner of the object, right? And I put a box around the object. I can't put a box around a triangle, an object that's angled like this. That means my bounding box is going to be looking something like this. This is what my bounding box is going to look like, right? Sorry, let's just get rid of this so you can see it. So this is what my real bounding box will look like for this object, right? Because I want to put a bounding box around the object. So I've got a problem here, right? I'm going to have a lot of logical collisions, but no physical collisions. Or sorry, no visual collisions, right? Or less visual collisions. So what separated axis theorem says is it says, well, if there's at least one axis, right? One face of the object that separates, right? There's a separation between at least one face and the other object. For example, if I could draw a line in here, this is the idea, right? If I could draw this line in here, there's no collision. That's what it's saying. Right? So if I can draw a line in here, at least on one edge of each of the objects. So here you can see that the edge goes this way, right? And here there's another edge over here, and there's another edge over here, and there's another edge over here. That's why I drew all those lines before, right? So these are all the edges around this object. This object has these edges. They're not aligned, right? They're not aligned. So I can say that as long as I can put some kind of line between the two objects, I don't have a collision. That's separated axis theorem. There's a separated axis, something that I can separate between them. And the way to figure this out is I project the points onto the axis that I have. So I project them down here like this. I project these points down onto the axis, right? Again, this is like computer science 101, guys, right? So, or actually more like game design 101, because you may not know about this even in computer science. So I kind of drag these axes down like this. And you can see that with all the, the corners, right, as I drag them down, none of them are overlapping these ones. I don't have an overlap here at all. There's no overlap. See that? No overlap here, no overlap here. They have different points on the x-axis, right? Similarly, I would do the same thing on the y-axis. Let's use this side as the y-axis. So I kind of do one of these. So I can say, okay, there is going to be overlap here, because if I project these points, right, project these points I'm doing my best here to draw this with this drawing program here, so bear with me. I project these points onto the y-axis. So I project these points onto the y-axis. Wait, I have overlap now because these points here from this object are in between these points. I have alignment, if you will, right? But I don't have alignment down here. Remember, one axis has to be separate, and I don't have a collision. So therefore, there's no collision, right? But separate axis theorem is a more complex algorithm. I have to do 4 checks times 4 checks, like a lot more checks, all right? It's way more accurate. It's way more accurate than distance formula because I check the object, I do my, my calculations, and I'm good to go. And in a 3D environment, this is pretty awesome too because I can literally check if my objects are if I have an axis, a plane. Think about a plane that I can put between 2 objects in 3 dimensions. Fantastic. But it may be too much for our game. So if you want to try and do it, you can. If you want to try and use different kind of collision system, you can try and look up separated axis theorem. I'm not going to cover that in this course because this is not a game concept course. It's a web game course, right? You need to know how to play, right? So I want you to build a game, not a game engine, right? I'm building the game engine for you, right? So to speak. If you overlap on, so that's a good. So if I do this, so right. So if I take this object, let's take this object now, and I go here, right? So it overlaps this way, but not this way, right? So if I go here, how about this? Like here, like this. So now it overlaps this way and this way. But how about over here? There's another area over here, another area up here, right? It has to overlap at least 3 axes, right, in order for you to have a collision because it has to do something like this. Like literally, it has to overlap here, here, and here, right? And you know what? Even better would be all 4 axes, right? So all 4 parts, all 4 corners, you'd have to, it'd have to overlap. And if you have that overlap, then you're good to go. That's why separate axis theorem is more accurate, right? But also more costly in some ways. More checks. You're doing more. You're doing not more checks. You're doing more branching. More if statements. If, until you get to this. Okay? Clear? So I wanted to show you this stuff because before we do collisions, you got to understand what I'm going to do, right? Why am I doing it this way, right? So I'm going to use this way. I'm going to use this distance thing happening. All right, but I need some structure for me to do this because I have half height and enemy half height because guess what? My game object that I built with you guys has half height. All of the game objects have half height. But I have no way of calculating distance. I haven't built that. And I want to be able to do it from anywhere. So I want to make a little bit of a math library. Okay, now I'm going to give you a full math library. Not now, but in another iteration when we get together, I'm going to have a full math library ready. You're going to download it, and you're going to just slap it into your code. And it's just going to go. Okay, I'm not expecting you to make a math library. I've already done it for you. Okay? But for now, let's make some simple changes to our code to add this thing in. So and again, I'm doing this slightly different from what I did earlier because I want you guys to understand how it works. So I'm going to go into my my code, and math library doesn't belong in core. It doesn't belong in objects. It doesn't belong in scenes. It belongs in math. It's a different thing altogether. You could also call it something else. But I'm making a new folder under my objects called math. Now, this is not JavaScript math. It's my math, my own math library. And I want to do 2 things. It doesn't make sense for my collision to have a distance calculator, right? It makes sense for my vector object to have a distance calculator. Think about it as a vector 2, right? Now, for people who are doing their own physics and stuff, this may help you, this kind of thing, this kind of thinking. So I'm going to do a new file. I'm going to call this vec2.ts. I want you to think about vec2 as a vector, a 2-dimensional vector. That's what it is. You could also think about it as vector 2D as opposed to vector 3D. So I'm going to do a module. I'm going to call this module math, a new module we never did before, right? And I'm going to export a new class called vec2. In my vec2 class, right, I'm going to have maybe some private instance variables. I'm going to have some public properties, which we're going to get to today. I want to see if I can do public properties too, which are really neat in TypeScript. I'm going to do some constructors, maybe some private methods, and maybe some public methods, which is where I'm going to put my public static stuff. So this is my vec2 class. By default, my vec2 class, I'm going to make it extend my createjs.point because createjs.point has x and y built into it. So let's just do that. I'm going to say extends createjs.point. The createjs.point class, if I look at the constructor function, I don't have to do this. I can make my own vec2, but it's already there. In my super class, it pulls in x and y coordinates. That's what it does. So what I want to do is for all vec2s for now, this is my simplified vec2. I'm going to give you a more complex vec2 later on. I'm going to give you a vec2 that you can pass in a vec2. I'm going to give you a vec2 you can pass in any two numbers, and it'll convert into a vector, right? I already have that all built. We don't have time today to build it, right? So I'm just going to make a simplified vec2. So in my constructor function with a vec2, I want to take in an x, which is a number, which I'm going to set to 0 by default, and a y, which is a number, which I'm also going to set to 0. So if you don't give me an x and y, I'm going to set it to 0, x and y to 0. And then I'm going to pass these values into my superclass, my super constructor. Right? So now my super constructor, when I make a new vec2 object, I'm going to make a point that has x and y set to 0 by default. Are you with me? All I'm doing is keeping track of x and y's. And by the way, in the future, I can use it for position. I can use it for a lot of other stuff, not just for this example I'm doing. So I could give my game objects a position object, right? All right, that's cool. I like this, but I also want to create a public static method now, so that actually takes in a vec2. Okay, let's do this. So public static. Remember, what the public static means? I don't have to instantiate the object, vec2, right? My public static method is going to be called distance. And it's going to take two objects, P1, which is of type vec2, and P2, which is of type vec2. Hold on. I'm just defining vec2, but I'm calling it here. So I need two objects. I'm asking for two objects now. I'm not asking for x and y coordinates, two whole objects. And I'm going to return a number, because my vec2 distance method should return a number, right? Okay, how do I do that? Well, I'm going to use my return statement to do the following. And again, this can be done different ways, guys. Please don't get mad at me, okay? Because math.square root, I'm going to pass in math.power. Again, you can say also P1 times P1 if you want to. Math.power of P2.x minus P1.x, right, to the power of 2, plus math.power. It's an exponent, right? P2.y minus P1.y, right, to the power of 2. And that's going to give you the distance, but it's going to give me a number, a floating point number. And if I want to reduce it, like I want to make it almost just pixels, then I'm going to just do a math.floor, and I'm going to reduce that to an even number. That's the distance formula. Questions around this? This is Pythagorean distance between 2 points, or Euclidean distance. Think of it however you like. All right, so two things. Distance between 2 points. So it's going to return a number, some number in pixels. But it needs two vectors, right? It needs a P1 vector and a P2 vector. The vector is just x and y coordinates for now. All right, if that's cool, we can add to the vector class at some other point. if that's cool, I've got my vector class. I'm going to add that in. So I'm going to say added vec2 math class, right? So I'm going to add this in, check this box, and push it to GitHub. So you have it now. But this has never been added in, right? So if I look at my index.html, I know that I need to add my math library a lot earlier than my managers, right? So I want to make a collision manager today, right? So somewhere, somewhere where it makes sense. So basically, maybe even before my game object, something like up here, like underneath my scene. I'm going to kind of make a new area that says here, math library. And for now, I'm just going to just add in my math, right? scripts.math.vec2.js, right? And just to be complete, I'm going to go in my core references and add that in too. And it's going to happen pretty much one of the first things. So notice what I did was I add my scene, and pretty much under my scene, I have my math library, right? So and the reason for this is because it has to come before game object, because maybe in my my new version of my game object, maybe I'll have a position or a transform or something that requires a vec2. So math vec2. All right, cool. So it doesn't matter about the spaces. So I've added my vec2 to my scene. Now I want to add a new folder for managers, because I want to make a collision manager here, right? Something that manages my collision. So I'm going to make a new folder. I'm going to call this managers. In my managers folder, I'm going to make a new file called collision. Oh, how about collision.ts? Collision.ts. There we go. All right. So in my collision.ts file, it's going to be a module that's going to be of managers, the managers module. I'm going to export a class that's called collision, a collision class. I'm not going to have a constructor because my collision class is just going to be a container, right? And I'm going to have a public static check function that's going to take two things. I'm going to take in object 1, which is of type objects game object, and object 2, which is of type objects.game object. So what this is saying is, hey, give me two game objects. I don't care what they are. It could be a plane, it could be an island, and it could be a cloud right now. Those are the three game objects I have in my scene. So I could do a check between plane and island, plane and cloud, or if I really want to, island and cloud, right? I could do any one of those, or cloud and cloud, right? Because it's two clouds or three clouds. So I could do that, right? But for now, I want to implement this thing, this notion, this thing we talked about, right? Now I need to have some, I know I need a vector 2 to pass into my distance formula for each of my objects. And right now, my objects don't have vector 2s in them, right? So I need to make a couple of new objects. So let P1 be of type, right? Be of type math.vec2. There's going to be a new math.vec2 object. And I'm going to pass in x and y coordinates, object 1.x and object 1.y, right? And I'll do the same thing for my second point. Okay, so when I do my check, I want to create these two objects temporarily. They're temporary variables I'm creating. Okay. In the future, we might want to add position for each of my game objects, which are going to be vec2s. And then we won't have to do this check. We won't have to do this thing. So here's my check. Here's my collision check. Yes, thank you. So this is, create two vec2s, vec2 objects that I'm going to use, right? Here, I'm going to say something like this. If, remember we created this thing? Math.vec2.distance, right? If my distance, it looks for P1 and P2, right? P1 and P2, right? If this is true, right? Is less than, in brackets, object 1 dot half height plus object 2 dot half height, then I have, my friends, a collision. We'll do a console.log to test, and we'll say collision, right? And just to follow up, this formula right here is exactly what we talked about, right? It's exactly what we talked about when we talked about inside of our code here, if distance is equal to less than player half height plus enemy half height, which is what our collision check is really doing, almost exactly. That was just our pseudocode. All right, we defined our distance formula. And now we're checking to see if object half height, whatever object 1 is, let's say the plane, plus the half height of the other object, let's say the island, is less than, if the distance is less than those two things added together, I have a collision. So it's distance calculations. Okay, let's add this collision manager, my first version of my collision manager, onto my into my game. I know that the collision manager must know about game objects. So, and maybe my ocean, my plane, my island, and my cloud, at least somewhere in here is where I should put my managers, right? Let's put them here for now. So I'm going to put, after game object, I'm going to make a new area where I'm just going to comment. I'm going to say game managers. And in here, I'm going to go something like, instead of objects, it's going to be managers. And then this is going to be called collision. My collision manager. And then in my core, just for completeness, I'm going to take this thing above game object, or after game object's been created, actually it has to be after. I'm going to add in my game object, my manager here. So it's going to be managers and then collision. So now I've added it into my my scene. No, my game. So I've got my first collision manager, but I need to test it. And to test this, in my play scene, where do you think I should test my collisions? Francis, where should I test my collisions? Which part of my scene? Huh? Won't be on the ocean, right? I got my start method. It's not going to be in there because I want to check it regularly, right? Update, right? Update happens every frame. This gets checked every frame. So, you know, this triggered every frame, right? This is what happens. Every frame, I do my island update and my cloud update. Well, guess what? I might as well check to see if they're colliding. So I'm going to do something like this. So check collision between plane and island. And you know what? Similarly, in here, check collision between plane, if I can type plane, and current cloud, whatever the current cloud is. Right? So that means I'm going to look something like this. Managers dot collision dot check. I'm going to pass in my two game objects, right? Which is this dot underscore plane and then this dot underscore island. Let's try this one first, then we'll try the cloud. All right. So if this works out properly, right, I'll be able to check to see if my plane and my island are colliding. Notice how beautiful this looks, right? It's nice because I'm calling a collision manager with a static function. I don't have to instantiate it, right? I'm just calling a collision check. That's all I'm doing. Very similar to what Unity does, by the way. All right, let's try this out. So let's see what it looks like in real time, right? So start, and let's see what if I get any collisions, right? Oh yeah, look, it's getting collisions, but I have a real problem. It's getting like hundreds of them. Look, it's like 37 collisions. Why is it doing that? Because as I collide with my island, right? I collide every moment of my island. I'm passing through my island and I'm colliding. And if I had a noise for this, if I had like sounds, it'd be like, yay, right? Because it would collide every single time, every moment, every frame. I don't want that. So I have a problem. I know I have a problem. Let's check to see if it works for the cloud, or because I did that here. It'd be the same check that I would do for the cloud, right? So the cloud manager.collision.check, the plane and the cloud. And not the cloud, but this cloud, which is inside of the for each loop, right? So if I did that properly, then the cloud should collide too. Look, oh yeah, tons of collisions. Oh, 73 collisions, 100 collisions. Woo, that's wrong. I only want to collide once with each object, once. So I need to have a state where I'm colliding and I'm not colliding. I got to be able to check if an object is in collision state or not, which means I need to change my game object. So if I go back to my objects, .game object, right, in here, I have width and half width and all this kind of stuff. I might as well add another public method at the bottom, or another public property at the bottom called isColliding, which is going to be of type Boolean. This is inside of my game object superclass. So now I can keep track of state. I can keep track of, is it colliding or not? And by default, in my initializer method, I'm going to set the fact that all game objects in the beginning, right, are not colliding. They're not colliding by default, right? When I make new game objects, it doesn't mean they're colliding automatically, right? In my initializer method. All right, so now that I have this new property for my game object that I just made, right, I can go back to my collision manager right here. And in my collision manager, instead of doing this, I can say, well, look, if this is true, if my distance checks out and I have a collision, and if I'm not colliding, then do something, right? And else, if I don't collide, then guess what? We'll say some object. It could be either object 1 or object 2, right? Let's use object 2. Object 2 dot is colliding. We'll set it to false. Why is that? Because, well, you know what? My distance calculation failed. I'm not colliding, so therefore my object is not colliding, right? However, inside of my collision check, I'm going to do something like this. If not object 2 is colliding, then only then are you going to say, I've got a collision. Let's take it one step further, right? Not only will I say that I have a collision, but I want to know which object I'm colliding with. And I've already done that work for you. I have a name. Remember last week we talked about this name property I set, right? I want to know which one. So collision with plus object2.name, right? So I know which object I'm colliding with. Okay, let's check this out now. So I should only collide once. This is the new thing, right? Per object. And when I collide, I want to know which one I'm colliding with. So cloud. Oh man, what the heck, right? What the? She's not working. That's right, because in here I got to say something like object2 dot is colliding is equal to true. When I'm colliding, I set it to true. Otherwise, set to false. Try again. Once. Right? Once. Once. But what about if I do this? Hold on. Right? I can cheat. Right? I can move back and forth a couple times. I'm really, really fast with my mouse. That's why we're going to change it from mouse to keyboard to prevent you from doing that so much, right? This kind of movement. I shouldn't be able to do that with my fingers, right? It's impossible, right? So, well, it'd be more difficult anyway. right? If I do this, I can do multiple points, right? I can drop the mail off twice, right? That's no cool. That's no cool at all. All right, so this is cool. I know which object I'm colliding with, and I can collide. I can check to see if I'm colliding. This is great, guys. This is the first piece. So my collision manager is complete. It works. So let's add that into our GitHub. So I'm going to add all this in. I'm going to say added collision manager. And by the way, this can work with any type of collision, but the guys who are doing their platformer game, so that's Daniel and Alexi, this type of collision, you have to think about this. May not be the right type for your game because you're doing a platformer, and this is more of two objects that are moving that are colliding. Your platformer you may want to do AABB collision because you've got a very simple platform that's squarish, right? And you want to overlap, right? Then you can do that a little bit differently. You still might you can also use both. You can use a hybrid if you really want to. You can do both distance and overlapping collisions, right? Just means more checks, slightly less performance. All right. So we have this stuff, right? We have our collision, and it'd be nice to get some feedback. Every time I collide, I want to hear some sounds, right? So here's part 2 of this. I want to add sounds to my game, right? So how do I do that? Well, in my core method, in my game.ts, remember I've been preloading. I preloaded all this stuff already. Well, I can also preload my sounds. And if you notice inside my files, in my assets, in my audio, I have engine.og, I have thunder.og, and yay.og. Og are just a sound format like MP3, right? This is just open sound format. MP3 is proprietary. Okay, so we're going to use this. I'm going to take this couple of lines here. I'm going to add it to my manifest. So I'm going to go 1, 2, 3. And I'm going to change this to yay, the engine sound first, let's say. I'll make this the thunder sound and the yay sound. This is a beautiful thing, guys. You're going to love this, right? Because that's how easy it is. Once I add this in, audio, right? In my audio folder, that's where I'm looking because I'm inside my assets audio. And then I'm going to go to my engine.og. And this is going to be my thunder.og. And I'm also going to do my yay.og. Right, there it is. So this is I've preloaded my sounds. That's all it takes to preload your sounds in Create.js. I've preloaded all my sounds in there, right? So now when I load up my game, it takes me a moment more, and I load up all my sounds as well. You can have preload as many things as you want, all right? Now this is how easy to play the sounds. So I want to play this in my collision manager, right? My collision manager is made to order. It's custom for me for my game, right? And what I want to do is when I collide with my cloud, right, then make one sound. When I collide with my island, make another sound. So then, let's just wipe this out. And let's make a switch statement on object2.name. And in case I'm colliding with my island, then do something. In case if I'm colliding with my cloud, well, then do something else, right? Pretty straightforward. And then maybe I have a default case when I don't collide at all, or I collide with something else. So if this is true, I can do something like this. I can say, well, create.js.sound.play yay. You're going to say, wait a minute. How can I do that? If you've been following along, you're going to say, wait, I don't understand how I have access to my sound object in Create.js. How do I have access to that? Because I never passed it into my collision manager. So how do I have access to it here? Wouldn't this fail? Well, this is the beautiful thing that I think you're going to like. As soon as you preload it, this global create.js.sound object automatically exists. So it makes sounds easy. So when I play it, it should sound like this now.
Yay.
right? Only once.
Yay. Yay.
I know, it's exciting.
Yay.
So that's all that's done through these two lines here. Create.js.sound.play, and then when I preloaded my sounds with yay or thunder, I just play those sounds and away I go. But what about a sound like a background sound, like a music soundtrack, or my plane has an engine sound, right? That I can want to play over and over again. Okay, well, you might be tempted to put it inside your plane, right? So you might go do something like this. Oh, well, my plane makes an engine sound, and when I instantiate my plane, here's my plane. When I instantiate my plane, I want to put it inside my start method. When my plane starts, I also start the sound. But what happens later on when I want to move from scene 1 to scene 2, level 1 to level 2 to level 3? I want my sound of my plane to stop. And I won't have access to it in here at all. So it's better to put any kind of background sounds in your scene, not in your game objects. So if I go back into my scene, which is my play scene, I want to do a couple things here for control. I want to instantiate a new object called engine sound. So this could also be your background sound, whatever you want to call it. It's going to be of type create.js.sound abstract sound abstract sound instance. This one. What this does, it'll keep track of my sound as I make it, and if I want to stop it, I can stop it afterwards too. So going down, I made my island, my ocean, all this kind of stuff, right? Maybe before main, right? In my game. My game actually adds stuff, right? It doesn't matter whether I do it here or there. What I want to do is I want to create my sound. I want to say something like this dot underscore engine sound is equal to a new, well, actually is equal to create.js dot sound dot play engine, which actually it's actually a factory method that creates a sound object and returns it inside engine sound. And then I can do some changes afterwards. Now, here's the problem when I do this. This only plays once, my engine sound. If I go back and I start.
Yay. Yay.
Oh,
Yay.
man. I want it to play forever, right? So in order for me to make this play forever, right, I want to modify this dot underscore engine sound dot loop, right? And I want it to add, make the loop -1. -1 means play forever. Play forever. You want to loop your sound forever? That's the way to do it. I also want to reduce the engine sound itself. It's a little bit too loud. And I can change the volume to make that like 0.3. So not as so loud. Because there's no control over the sounds, how loud they are. If you record the sounds really loud, they're going to come all loud, the same thing. So you can modify your sound here for each of the sounds. Sounds is actually pretty tricky and computationally expensive, actually. A little nicer.
Yay.
Right?
Yay. Yay.
That's pretty cool. So I can modify my loop, I can change my volume, and I can play my engine sound. Questions so far? So we did my collision manager, but man, like I got no way, absolutely no way of knowing what my score is. Like I got my sounds. I mean, this is a great opportunity for me to add a scoring system, right? Because if I get hit, I can score. If I get hit, I can lose my life. If I can kind of go over an island, I can get some score. And if I have 0 lives, I can transition to my game over screen, right? So I did it differently this morning. I'm going to build my scoreboard class now. But first, I'm going to put what I have. I just added sounds to the game. I'll say added sounds the game. We have that as well in a separate commit. It's all part of collisions, right? Sounds, because you can't make sounds without collisions, right? You need collisions to generate the sound effect, to give feedback to the player, right? At the same time, we also want to be able to score. You can't do scoring without some collisions, or have a scoreboard, so you need to have this part too. So again, we think about this. I want to think about a couple things. My managers right now have a collision manager. I want to make a scoreboard manager, almost like a user interface, that I want to layer on top of everything else. It's going to be the last thing I add to my scene, right? But I want it to be flexible enough so I can call it up if I need to in my game over scene. In my game over scene. So what I'm going to do here is I'm going to make a new file, a new manager called scoreboard.ts. In my scoreboard manager is going to be inside the module managers. It's going to export a class called scoreboard. Actually, I'll make it scoreboard like that. I'm not going to extend anything. And it's going to contain some private instance variables. And you know what? I'm going to make some public properties this time around, real public properties. Some constructors, maybe more than one, I don't know. Maybe some private methods. And maybe later on, not today, some public methods. This is my scoreboard. My scoreboard is like my UI for my lives and my score and some other messages, right? So you got to think of what this does. So I need some private instance variables. Now, typically what we've been doing is I'm using public instance variables. That's what we've been doing. And I want to move away from that going forward, right? In fact, later on, I want to go back and change everything to getters and setters. But how do getters and setters work in TypeScript? If I go back to TypeScript, getters and setters look like this. This is on the TypeScript lang.org docs handbook _ under the classes. You can see that there's getters and setters here. This is how they work, right? It's just different syntax. I have my private data member, and then I have my getters and my setters. Okay, pretty straightforward. Let's try this out. So going back, I have my private data member. So I'm going to say private. I'm going to have 3 of them. I'm going to have something called lives, which is a number. I'm going to have something called score, which is a number. I'm going to have something called high score, which is a number, right? Then in my public properties for the first time, I'm going to, instead of using public, I don't have to use public anymore. I can just use get and set. So if I say get, it's public. Get lives, right? Which is going to return a number, right? And I'm going to return this dot underscore lives. It's like we do in other programs, other languages like Java. And I'm going to set lives, right? Where I'm going to pass in new lives, which is a number, right? And I'm going to say that this dot underscore lives is equal to new lives. However, I also want to update here my scoreboard, my score label. Why not? If I'm setting the score, update the label too. And that's a great use case for getters and setters. Instead of doing one thing, changing the data member, also do something else. So that means up here, instead of just having these variables, lives, score, and high score, I'm going to have some public, now this is where I'm going to have some public instance variables or public objects, if you will. I could also create getters and setters from these, but I only need a getter because it's a reference type. But for now, let's just make it like this, where I'm going to have my public, I'm going to call this thing lives label, which is of type objects.label, and a public score label, which is of type objects.label, and a public high score label, which is of type objects.label. You're going to see how this plays into things later on. So inside my live setter, I can just also do this. I can say, well, set lives, and I can say that this dot lives label dot text is equal to lives plus this dot underscore lives. Right? So I can change the text of the lives label every time I change the live, right? Which is way better than detecting, saying if this changed, then change this. Don't do those. I don't need to do ifs here. It's automatic, right? And the same thing goes with, let me just copy paste, because we're going to do score and high score. So score and high score, they all say lives, but here's what it would look like: score, score, new score, new score, score, score. It's just easier to fill in as opposed to make it new. Score label, score, and score. Okay. And the same thing goes with high score, new high score, new high score, and high score label, which says high score and whatever the high score is. Okay. I've got a bunch of getters and setters now, public properties that we've never seen before. We've never done this with you guys with TypeScript. Okay. In my constructor, I don't have a superclass, but what I want to do is initialize. So I'm going to, in my private method, I'm going to make a private initialize method and return void. And it's basically going to be called by the constructor. And what it's going to do is it's going to do something like this. I'm going to say that this dot lives label is equal to a new objects.label. I'm going to pass in something that says lives. This is what it's going to set up like. And for a font size, we're going to choose a font size of 20 pixels and a font family of consolas and a font color of yellow, FF00. X and Y values 10 and 10 on the left side. And is it centered? No, false. I don't want it to be centered. That's my lives label. I'm making a lives label, so the top left corner of the screen, you're going to see lives, right? Now remember, this is not added in yet. It's just initializing. I'm just making this label. And I'm going to make, instead of a lives label, we're going to call it score label. Score label is going to be of type objects.label. Instead of lives, it's going to say score, right? And just to be clear, maybe live 0 just to test it, and score of something like 5 nines. Give me some space to test to see if this is right. 20 pixels consolas, yellow. I'm going to go at someplace about 500 this time on the right, towards the right of the screen, right? And the last one I want to make is I want to make a high score label, which I'm not going to use in my main scene, in my play, right? So I'm going to make it that high score label for now. I'm going to say high score. And it's going to be, instead of 20 pixels, it's going to be pretty big. Make it 40 pixels. It's going to be yellow. I'm going to make it centered this time. So this is going to be 320 and 240 for now. And I'm turning this to true. So it's going to be a centered label. All right, so I've got my labels. Well, guess what? I want to initialize my lives and my score and my high score. I'm going to say that this dot lives, I'm using the getter here, and this, or the setter. This dot lives is equal to 5. This dot score is equal to 0. Oops. And this dot high score is also, for now, going to be equal to 0. That's it. That's my score manager or my scoreboard. So this keeps track of everything, but this is one that I need to instantiate. I can't make this a static class because it keeps track of a bunch of stuff, right? So in order for me to make this work in my index, I got to add this in. I need to know, my collision needs to know about my manager. So I'm going to put this on top of collisions. This is going to be a manager scoreboard. And inside my core reference, just to be, again, for completeness, for now, I'm going to put this in here as well. Okay, so that's my scoreboard. Testing. How do I use it? How do I use this thing? It's got to be inside my scenes. So in my play scene, I'm going to create an object called scoreboard, right? So private scoreboard, which is equal, it's of type managers dot scoreboard, right? And what I want to do is I want to instantiate it along with everything else. So in my start method at the bottom, before main, I'm going to do something like this dot underscore scoreboard is equal to a new managers dot scoreboard. Okay, so that's where I instantiate. I kind of create the scoreboard user interface for the scene. That's what it is. And then in my main function, where I add all my children to the scene, I'm going to add it last because I want it to hover above everything else. It's not going to be underneath the clouds. My scoreboard is going to appear way at the top. Okay. So add scoreboard labels to the scene. Notice how I said that. It's going to be like this. This dot underscore scoreboard dot lives label, right? I want to add that to the scene, which means I'm going to do something like this dot add child, this dot scoreboard label lives label. So I'm adding that to the scene. It means that when I make them in my scoreboard, they're not automatically added to my scene. I can choose to add whichever ones I want. Different way of doing things. Okay. So both of those got added to the scene. All right, let's check it out. Man, we did all this work. I haven't tested my scoreboard. I haven't seen if it's even going to work, right? First of all, we're going to go back to here and we're going to click start. And you can see now that my scoreboard appears above my clouds, but nothing is happening.
Yay.
Nothing is happening because my collision manager hasn't done anything. It's not going to react to change anything. Uh-oh. My collision manager know about my scoreboard? No, it does not. So the quick fix around that, instead of passing things around again, is going into my objects.game. By the way, objects.game probably should be a game manager, right, as opposed to a game. I can add in another object called public static. We'll call this scoreboard, which is of type managers scoreboard. And then when I instantiate this the new scoreboard inside of my scene, the place where I instantiate it, which is up here in my start method, I'm going to make a reference. So I'll say objects.game.scoreboard is equal to this dot underscore scoreboard. Now when I've done this, I have access to it anywhere. right? So I can go to my my collision manager now, where I detect island is yay and cloud is thunder. I can say that objects .game .scoreboard I'm yay. I want to get score, right? Score plus equals to 100. I'm getting 100 points. Now, when I change my score, because it's a getter as a setter, I'm also updating my scoreboard automatically. So my label is going to be automatically updated, right? And the same thing goes with thunder. Objects .game scoreboard lives, right? I'm going to put minus equal to 1. You can also put minus minus. I like minus equal to 1. It's a little clearer. So I'm subtracting 1 life every time I hit a cloud. So I got lives and score. And when I go back, I start.
Yay.
I got 100 points.
Yay.
I got 200 points.
Yay.
I got 300 points. I didn't die.
Yay.
400. And if I die. Wait a minute. I got like -3. This is a great place to switch scenes. Now that I know I've got -3, or anything less than 0, I can switch my scenes to my game over scene. That's my condition. I satisfy the conditions of switching, right? So that means that I'm not going to do it here in my collision manager. I want to change it in my scenes play scene. And I'm going to do that inside of my update method. So I check collisions, I do this stuff, blah, blah, blah. And then I'm going to say something like this. I'm going to say, well, if objects, or actually I can check my own, this built-in one, this _scoreboard lives, if my lives is less than or equal to, less than or equal to 0, because sometimes you hit more than 1 cloud, and then it'll take you below 0, right? So you can't just say less than 0 or equal to 0, right? If it's less than or equal to 0, then what I want to do is I want to switch my scenes. I'm going to say objects.game. And just to be sure to see what you can do with the game object, remember? It has a current scene object. Current scene is equal to config.scene.over. What this does is it changes the state of my game. It moves from my play scene to my over scene. Guys, this is critical for you to have all your scenes working, right? When you die, you go to the game over scene here. Okay, that's how it switches right here. So if lives fall below 0, switch scenes to the game over scene. So this is done. Try this out and see if it works. So die. Uh-oh. What the heck? My engine's still playing. Remember I told you that it's going to be a problem because you need to control your engine sound. It's the engine, the sound object is a global object that works throughout your entire game. So even if you remove your scene class, it doesn't matter. The game object still, the sound object still exists. It's a bit of a memory leak unless you turn it off, right? And so the way to do that is, well, we instantiated the sound up here as engine sound. And what we can do is when we switch, before we switch scenes, let's just turn it off. So we'll say that this _engine sound, right? Stop. Stops the sound. So it won't go to the next scene.
Yay.
Right? Yeah. Because collision is a generic class, and I don't want, remember, my collision can be in any scene. So if I put it in collision, it's always going to go to the game over scene, right? But maybe in some sense, I don't want it there. I want to be able to control it in the actual scene itself. True. But I also can do a lot of things. And the reason why I'm doing it this way is so that way I want to be able to, in my mind, I always think about it like, okay, if I want to change stuff, you can see that I've got some kind of deprecated code in my code too. What I want to do instead is control it in my scene, because maybe you might die, and you might want to take yourself to not the game over scene, but somewhere else. Like, for example, some other scene that says, you know, you have 3 seconds. Do you want to continue? Do you want to continue? Do you want to continue? No, game over, right? Which is gives you more control. All right, so this is I've covered so far, and this is a great place to stop for a small break, right? And stop the video too. I've covered collisions, I've covered sounds, and I've covered the Scoreboard Manager. Let's put this up on GitHub. So added Scoreboard Manager, right? That's most of the stuff you need for your first playable. Again, your first playable is due Monday. All right, I moved the due date to Monday. Gives you an extra day or two to work things out, because you didn't have collisions. I didn't give you collisions, and I didn't give you movement without the mouse, which is what I'm going to do after the break. When we come back, I'm going to create a keyboard controller class, which allows you to move things with your keyboard as opposed to your mouse, because your mouse sucks when it comes to platformers, when it comes to some other thing, like, for example, tank games and so on, right? And it's a lot of control. Like, for example, one thing that you can do with your keyboard right now, or mouse, I can cheat when I play the game. Remember? Look. I can do one of these, right? I can do... Oh, wrong.
Yay.
I can try and...
Yay.
Yeah, well, that didn't work.
Yay.
There, see that?
Yay.
See? And I can move really fast, too, like this, right? Which I shouldn't be able to do. A plane shouldn't be able to move that fast, right? A plane should never move that fast. I shouldn't be able to do this kind of thing, right?
Yay.
So I should be able to stop myself, and if I have keyboard controls, it'll give me more control, more realistic movement, and more retro gaming kind of feel too. Let's take a short break, and when we come back, we'll continue with our keyboard controls.